Good morning and welcome back. Today we are going to start off by doing a little bit of review related to parallel lines. And as you can see here in this picture, we have a parallelogram. It says up here on the top left, the shaded parallelogram is created from two pairs of parallel lines. So if we look here, we'll see these are parallel and these are parallel. Once again, remember, we know they are parallel because of these little arrowheads. So right here, there's 1 and 1. There's 2 and 2. Okay, so that's what shows us that the two sets of lines are parallel. Now, because of that, we can identify a few of these statements to be true. So 4 statements that we can identify to be true. And we're going to try to match them with which of these allows us to know that. So right here, angle 4 is congruent to angle 12. If we look here, angle 4 and angle 12. Now, compared to these two parallel lines cut by the transversal, both down to the right, those are going to be known as corresponding angles. Okay, so letter A here matches with number 3, corresponding angles. Number 11, angle 11 and angle 14. Angle 11's here, angle 14's here. They're on alternate sides, and between these two sets of parallel lines, they're on the interior, they're inside. So alternate interior angles. Letter B will go down here. And we know that both corresponding and alternate interior angles are congruent. Okay, as both of those are marked. Now these next two both add up to 180. They're supplementary. If we look here, 12 and 14, they add up to 180. They are both on the interior, and they would be consecutive interior because they're on the same side. Same side interior is another name. So that'll be number 1. And then the final one, letter D, angle 2 and 8. And this one you're not always going to see, but it's not as common. But this book does point out it's consecutive exterior. So the same as the consecutive interior, also means same side. The only difference is exterior because it's on the outside. All right. Now, as we were talking about parallelograms, if we look here, the next section here says solve for x, and then is this red quadrilateral a parallelogram? So if we look here, maybe it's a little hard to see, but right here, if we zoom in, the quadrilateral right here, we know it's a quadrilateral because it has 4 sides. So 1, 2, 3, 4. And it asks, is it a parallelogram? Now, we've learned a few things about parallelograms. First off, we know parallelograms have opposite sides that are parallel. That's probably the easiest. And from this, I'd say it looks pretty close. It looks like they are. I mean, I would believe it if you told me they were. But to prove it, if we knew that they were parallel, if there were marks, we could prove it. There are not marks. Instead, we can look at these angles, though. And we know on a parallelogram, opposite angles are going to be congruent. Okay, so if we look here, this is 68, and the opposite one is x. So in order for this to be a parallelogram, this x would have to be 68. Now, here's something else. 110 is over here, 112. Those are not the same. It is not going to be a parallelogram. It's very close, but not quite. The other thing we can think about, remember on a quadrilateral, we know it always adds up to 360. So right now we have 112, 68, and 110. If we add all that up, we get 290. So we take 360 minus that 290. We will find that x is 70 degrees. That is what x equals. So is this a red quadrilateral parallelogram? No. It's very, very close. But the opposite angles are not congruent. Now, another thing we could have checked is, are consecutive angles going to add up to 180? Are they supplementary? Let me write this quick. And that depends on which set you look at. So over here, 68 and 112, that does add up to 180. Meanwhile, 110 and this side 70 would add up to 180. But when we go across this way, 110 and 68, that'd be 178, 112 and 70. That's 170 or 82. So not quite. Now, today we are going to talk about the converse of some of the rules we learned last week. So last week we learned that if things are a parallelogram, we know that the opposite sides are going to be congruent. Now, the converse of the opposite sides of a parallelogram just states if we see a shape, a quadrilateral, and it has opposite sides that are congruent, right away I know it's a parallelogram. So we look here, AB has one mark, DC has a mark, AD has a mark, or 2 marks, BC has 2 marks. That means they're congruent across, opposites are congruent, which means it has to be a parallelogram. I don't know if you remember converse from let's see, that was chapter 2, I believe, back in August. And most of you didn't have me back then, but the converse was when it reverses our statement. So instead of yesterday, or I guess I should say last week, we learned that if something is a parallelogram, then the opposite sides are going to be congruent. And this is saying the converse is if the opposite sides of a quadrilateral are congruent, then it's a parallelogram. So that's one rule we know. A second way to prove shapes are a parallelogram is if both pairs of opposite angles are congruent, then the quadrilateral is also a parallelogram. So if we look here, B and D, they're marked with 2 arcs. A and C are marked with 1 arc. If that is the case, that will always mean that the shape ABCD is a parallelogram. Now, if you would rather, you could call it ADCB or CDAB. The rules when you're naming these polygons, we want to start at one point and then trace it around in order. Okay, so a third rule, another converse here. So I guess that was our converse of the opposite angles. Okay, the third rule is the converse of our diagonals of a parallelogram. Now, you guys hopefully remember last week we said if it's a parallelogram, that means that the diagonals bisect. They cut it equally in half, right? Bisect 2 sections, cut in half. So the converse states if the diagonals do bisect, then we know that it is a parallelogram. So if we look here, AE and CE are congruent. Meanwhile, DE and BE are congruent. So if that is the case, it is a parallelogram. And our final one, this one might be a little bit not as intuitive as the first 3, not quite as directly related to what we learned last week. But this one's not a converse. It just says the opposite sides criteria. So we can call it opposite sides criteria. And this states if on a quadrilateral, one pair of opposite sides are congruent and parallel. So not only are they parallel, they are also congruent. If that is the case, then that automatically tells us it's a parallelogram. That is the only way that it is possible for them to be both parallel and congruent, is if these two are also parallel and congruent. So, with that being said, question C here asks, do we have enough information to conclude that FGHJ is a parallelogram? Explain. So if we look here, FGHJ, and already solved for you, I got here the distance formula. If you forget what that is, simply finding what our change in x is and our change in y. So GH here, we plugged in the points 3, 2 and 3, 1. Or sorry, GH, so 3, 2 and 2, negative 2. So 3 minus 2, the change in x, and then we'll square that. And then the change in y, 2 minus negative 2, square that. If we add that together, we get square root of 17. Do the same for FJ, so that's going to be square root of 17. Now, you might not know what square root of 17 is, but the key is, if they both are square root of 17, even if we don't have a clue what it is, we know it is congruent. Okay, so right away, GH and FJ, I can mark, let me do this in a different color so it stands out. I can mark this as congruent to the opposite side. All right. Now, the question says, do we have enough information to conclude that it is a parallelogram? And explain. Now, this is kind of a confusing question because right now, do we have enough things marked? No. However, do we have enough information to conclude it? That depends on what you consider information. At this point, we have not talked about enough things to conclude it. Just because two of these opposite sides are congruent does not mean it's parallelogram. However, I can use the information I have on this picture to make a few more conclusions. Now, one thing we could do is we could find what are these two sides' lengths. I could use that same method, the distance formula, and if they were congruent, then that would show that our shape is a parallelogram by the converse of opposite sides. And if we wanted to do that, we could. However, I think there's an easier way, and the easier way is using rise over run. Now, it's up to you. If you prefer, you can just find, is that congruent? Is that congruent? We could use our formula. So x2 minus x1 plus y2 minus y1. We square both of those, and it's the square root of all that. That is our distance formula. Okay, we learned that back chapter 1. You probably saw that several times throughout this semester 1. So we could use that and figure out if FG and JH are congruent. But I think a way that'll be quicker instead is, remember this last rule, opposite sides criteria for a parallelogram. If our opposite sides are congruent, which we already know they are, if they are also parallel, then it's a parallelogram. Now, if GH and FJ are parallel, that would mean they have the same slope. So all we have to do is figure out what is the slope of each of them. Now, that can be very easy. You could use a couple different ways. You can do, right here I'm writing the formula, y2 minus y1 over x2 minus x1. That's one way. However, I think there's an easier way. We can use rise over run. So right here, if we start at h, up 1, 2, 3, 4, that's our rise. Run is 1. So the slope of, oops, I was pushing down a button I didn't want to push. Let me erase that quick. The slope of GH equals, we said, up 4 over 1. So that's 4. Okay, meanwhile, the slope of FJ, once again, up 1, 2, 3, 4 over 1. So if the slope of FJ is also 4 over 1, if they have the same slope, then I can put the little mark on there. They are parallel, okay? And if they are both parallel and congruent, then that tells us the opposite sides criteria holds true, and we know that our shape FGHJ is a parallelogram. All right. So now we have 4 different quadrilaterals here, and we are wanting to know which of these theorems that we talked about shows that they are parallelogram. So if we look at this first one, these two opposite sides are marked with 15s. If they're both 15, we know they are congruent. Top and bottom are both marked with 1 mark, so we know those are congruent. If you wanted to, you could add 2 marks to each of these 15s, just saying that they're the same. You don't have to, that's kind of optional, but you can put that marking on there if you want. But also, if we have a 15 and 15, we know 15 is always going to equal 15. Okay, so this would be our converse of opposite sides. All right, the second one here. On the second one, only one set of sides is used. The opposite sides are both congruent and parallel. Okay, so this was our opposite sides criteria. It's not a converse. And I should say, we've talked about 4 ways to prove that shapes are parallelogram. The 5th way is if both sets of opposite sides are parallel. If that's already given to you or you know that, then that is another way. They would also be parallel. All right, in the final row here, opposite sides 102, 102. Meanwhile, these arcs are there. And since they are congruent, we know it is the converse of opposite angles. And it is a parallelogram. Now, it does not ask us this, but if it did, could you find what those missing angles were? And I hope you could. If not, there's two different ways you can think about it. One is we know that these all add up to 360. You add 102 and 102, you get 204. Take that from 360, we'll be left with 156. And we'll divide it by 2 because these two opposite angles are congruent. 156 divided by 2 is 78. The other way you can do it, since we proved it was a parallelogram, now we know that consecutive angles are supplementary, or they add up to 180. So 180 minus 102 leaves us with 78 right there. Now the final one here, number 4. We have our diagonals, and we don't know what this length is. We just know that these two marks are the same, which means it is bisected because each of the diagonals is cut into 2 equal parts. So our final one will be the converse of the diagonals. That's what allows us to determine that, yes, this is a parallelogram. All right, I'm almost done with the lesson. The last thing I want to talk about is if we have these, oops, I'm going the wrong way. We have 4 of these I want to look at. And it says, determine whether the quadrilateral is a parallelogram. Explain your reasoning. Now, we don't need to do a ton of work on this. In my opinion, when we have them on graphs like this, the easiest thing to do is just use rise over run and decide, are the opposite sides parallel? If both sets are, then we know it's parallelogram. Okay, the other option is you could find side lengths. You could get a protractor out and measure angles. But in my opinion, the protractor is definitely going to be the hardest, to be precise. And then the side lengths will take a little bit more work. So instead, we'll just use our rise over run. So if we look here, this is up 1, 2 over 1. So that has a slope of 2 over 1. Our next one, up 1, 2 over 1, 2. That would have a slope of 2 over 2, which reduces to just 1. 1 and 2 are not the same. So is it a parallelogram? No. Our next one, 21. Rise of 1, 2, 3, 4. Run of 2. So if we think about that, 4 over 2, which reduces just to 2 over 1 or 2. Meanwhile, in this one, up 1, 2, 3, 4 over 1, 2. So another slope of 4 over 2, which is also 2. So those are congruent. Those are equal. So we know that the first set is parallel. Now we could either find the distance and show that those sides are congruent, or the other way, which I think is easier, is let's just use rise over run on those other sides. So right up here, you might go up 1 and then left 1, 2, 3. Now keep in mind, if it's up 1, left 3, that's 1 over negative 3. Left is negative. Now someone else, maybe on the bottom one, starts on the left and goes down 1, left 1, 2, or right 1, 2, 3. That's okay because down is negative, right is 3. 1, let me write this here. If I have 1 over negative 3, that is equal to negative 1/3. Or you might even see it written like this. All 3 of these are equal. They are all congruent. They are all the same. Okay, which tells us if they are also parallel that this is, yes, a parallelogram. Okay, 2 more. I'm going to spend quite as much time now that we've kind of dissected that. So rise of 1, 2 over 1, 2, 3, 4. So 2 over 4, which reduces to 1/2. Up 1, 2 over 1, 2, 3, 4. Slope of 1/2. So those two are the same. Down 1, 2, 3 over 1, 2, 3. So negative 3 over 3, which is negative 1. Meanwhile, down 1, 2, 3 over 1, 2, 3. Negative 3 over 3, which is 1. They are the same. So yes, this would be a parallelogram. Final one here. And hopefully you can tell just by looking that this is not. But if you can't tell, if we look at the top, right, up 1 over 1, 2, 3, 4, 5, 6. So that's 1 over 6. On the bottom, it does not go up at all. Now it's over 1, 2, 3, 4, 5, 6. But it'd be 0 over 6, which reduces to just a slope of 0. So are they parallel? No, which means no, it cannot be a parallelogram. So there is nothing new to do for today. There's no new assignment. If you watch this, you're good. However, make sure that if you have not been keeping up to date on the Delta Math, you sign in and use the rest of the time to work on that. Okay? If you have any questions, please reach out. I know this isn't ideal with me not being there, but please try to stay up to date and caught up on our assignments, and then I can help you if you need help when I return. So hope you have a great day, and